Hi everyone. Welcome to this webinar today. So this is our first IAM webinar for the year 2018. My name is Johan and I am a Senior Lead Solutions Engineer at WSO2. I was previously in the WSO2 IAM team as well as the product architect. So today's webinar topic is going to be 2018 IAM checklist, best practices, trends, and the future. So what we are going to look at today is the different type of IAM offerings that you have in the market that you can choose from, and the different delivery models of identity and access management. And then what are the hot kind of trends that you find and what we can expect in the future. And I'll also like touch upon some of the highlights that will be coming in the upcoming versions of the WSO2 Identity Server and our release themes for this year. So the shifting of enterprise applications to the cloud, the proliferation of devices and the diversity of the users have forever changed the landscape of identity and access management. So we witness organizations of all sizes and verticals increasingly realizing the importance of SaaS, SaaS, customer IAM, business-to-business IAM, and workforce to, or rather traditional workforce IAM use cases. And we find small, medium, and large enterprises investing heavily in order to tune their IAM strategy. Whether you are a publicly traded corporation, a government institution, or a small to medium business, or even a startup, IAM is very essential for you than ever before. So before we move into the topic itself, I just wanted to show you the IAM team. So in fact, last year has been a very wonderful year for us. So we celebrated our 10th year from the time we released Identity Server 1.0. So there have been some key achievements during last year, which I would like to highlight since this is the first webinar for the year. We reached 100 paying customers for the WSO Identity Server, the Identity Server alone. And currently, WSO Identity Servers manages more than 40 million identities across the world. And one of the unique highlights of Identity Server compared to any other product is that there is a lot of open source, there is a lot of organizations that are using Identity Server as a free and open source product. More than 100 organizations managing more than tens of thousands of identities using the free and open source version. So we have a very strong open source community as well. And also the Mobile Connect support enables more than 900 million users in India to access their favorite applications using a mobile phone, which calls go through the WSO2 Identity Server. So now I think we'll move to the topic. So identity and access management can be broadly categorized into 4 key use cases, more or less in any kind of industry. We will look at these different use cases in little more detail in the upcoming slides. But namely, the use cases are traditional workforce, that is the B2E, where your employees access your internal applications. Then we have the B2B, they are your partners, your suppliers, your distributors will be accessing your applications. Then we have the more recent model, we have the workforce to SaaS model. Your employees are accessing SaaS applications like Salesforce and Google, etc. Through the on-premise IAM. And then we have, of course, the new business to customer, that is the customer identity network management or CIAM use case. Another way of categorizing is based on the IAM delivery model. It can be on-premise, cloud, or hybrid. So we'll look at these options in detail in the upcoming slides. So today, only around 10% of IAM usage accounts to traditional workforce IAM. The remaining 90% accounts to either workforce to SaaS or CIAM use cases. Even in the case of WSO2 Identity Server, almost 80% of the use cases are workforce to SaaS or CIAM or CIM. What's important to understand is that these use cases don't have mutually exclusive sets of requirements. Almost all the requirements are found across the various use cases, however, at different levels of importance. And you necessarily don't need to have separate IAM products to solve each of these use cases. However, it's also not practical to find one product that solves every IAM use case you would have. Therefore, what's commonly found is multiple IAM systems working together in an ecosystem-like manner, each doing what they do best. Recently, the IDaaS market, which was originally fueled by small and medium businesses that used SaaS as the predominant application delivery model. Most of their applications already were in the cloud and they preferred to buy rather than build infrastructure. In turn, SaaS applications became new identity silos, each with their own administration, access, authentication, and event logging capabilities. IDaaS vendors use this opportunity to create integrations with SaaS vendors for the purpose of authentication, single sign-on, and account management. In doing so, this allowed IDaaS customers to enjoy seamless integration with a wide variety of SaaS applications. IDaaS vendors also can bridge customers' on-premise identity and authentication services and use data held or copied from there to provision and deprovision accounts on SaaS targets. This automation saves customers the effort of manually provisioning and deprovisioning accounts, and also can help to avoid orphaned active accounts on SaaS that can leave organizations vulnerable and paying for unused accounts. The web-centric IDaaS providers support web and mobile architected application targets in the cloud or on-premise or customers' premises. Web-centric IDaaS providers generally have strengths in multi-factor authentication and single sign-on. The web-centric offerings tend to support the basic user administration, self-service, and identity synchronization aspects of identity governance and administration, but lack legacy application connector support and customizable multi-level approval workflow and governance features such as access certification, role mining, and role lifecycle management and segregation of duties detection. Web-centric IDaaS usually deploys rapidly because the services are designed to be multi-tenant, and customization and legacy integration requirements are not the primary design goals. Organizations are encouraged to identify IAM business drivers and constraints, as well as the use cases and depth of IAM functionality that must be supported to determine if the IDaaS delivery model is a good fit for your organization. Requirements such as speed to implementation, the geographic coverage, total cost of the ownership, and data residency are most likely to strongly affect choices for a shortlist. So first we will look at the traditional workforce IAM. The traditional workforce IAM use case focuses on requirements of on-premise application targets. These can be web applications as well as desktop applications. These applications require more functional depth in identity governance and administration as well. Legacy full-featured IDaaS providers have services that were developed to support web applications on-premise as well as legacy applications. More IGA connectors, or other identity governance and administration connectors, are available for legacy applications, and customizable approval workflows are supported. More of these vendors are also providing governance features such as access certification, role mining, and role lifecycle management and detection of segregation of duties violation. Legacy supporting implementations can be deployed rapidly, but will generally take longer and be more costly because of more advanced IGA features they support are needed by large organizations, often from regulated industries and with complex requirements. Also, customized IGA implementations often need implementation support from system integrators. Clients generally should expect more complex, time-consuming, and costly implementations when they have requirements for IGA functional depth and when they have legacy on-premise application targets. These requirements generally indicate a stronger need for IAM process and data modeling and target system integration functions such as connector development and configuration. In recent times, some IDaaS vendors have proven that they can deliver the functionality from the cloud that traditionally has been provided by full-featured IAM stacks managed within the enterprise, such as multi-level provisioning, approval workflows, as well as identity governance features like access certification, segregation of duty policy enforcement, and role lifecycle management. While IDaaS is expected to offer ease of development, deployment, implementations are more complex, time-consuming, and costly when organizations have requirements for IGA functional depth and when they have legacy on-premise application targets. What we see here is a selection of features that you would commonly find in the B2E IAM use case. Mostly in the B2E IAM use cases, the channels that you find are desktop applications and web applications. It's not common to find mobile applications. The logins are mostly used through Windows authentication or connects to your LDAP or database. For strong authentication, you would commonly find RSA Secure ID kind of tokens or smart cards. And the predominant single sign-on protocol used in enterprises tend to be SAML to single sign-on. Then the next use case we have is the business-to-business use case. This is where you allow your partners and distributors and suppliers to access your internal applications using federated identity. This is also very similar to the SAML-based single sign-on, except the login, the authentication happens through a federation. The key features that you would find in this kind of a model is basically federation and just-in-time provisioning of accounts and entitlements. Then we come to the workforce to SaaS use case. The workforce to SaaS use case focuses on IAM for SaaS applications for employees. This use case is primarily driven by the need to extend basic IAM functions and serve employees accessing SaaS applications. This need is often viewed as lower hanging fruits than replacing an established on-premise software suite implementation that supports legacy applications. IDaaS vendors prove compelling for organizations with significant or increasing SaaS adoption, particularly if it is having difficulty maintaining staff IAM expertise. Given this context, the SaaS application integration critical capability is weighted most heavily for the workforce to SaaS use case, followed by authentication, profile management, password management, access request, and workflow and mobility management. As these vendors have moved upmarket, they found that large organizations tend to have IAM products in place. These large organizations also have deeper IGA functionality needs than web-centric vendors can provide, as represented by traditional or legacy workforce use case. In addition, prospects with deeper IGA functionality needs typically require integration into legacy systems. This forces shallow-functioned web-centric IDaaS vendors to add deeper functionality and integration capabilities with traditional workforce IAM systems to their roadmaps. Several IDaaS vendors today have integrated EMM offerings and have either made acquisitions or have partnered for integration in the cloud access security broker market. What we see today is that the fuzzy line between web-centric and full-featured offerings will get even fuzzier in the future. Overall, by 2020, 40% of IAM purchasers will use the IDaaS delivery model, which is currently at around 20%. Of those IDaaS implementations, 40% will replace on-premise IAM implementations, rather than simply augmenting those implementations. The final use case we see is the business to customer or CIAM use case. The CIAM use case focuses on IAM to on-premise and cloud-based web applications for customers. This use case has grown in importance as organizations look to provide customers access to their online applications. Social identity integration can significantly enhance a customer's user experience by reducing login and account creation friction, and also by providing attributes that enable a website to provide a richer, more personalized experience, in turn deepening customer intimacy. Accordingly, this critical capability is weighted most heavily for the CIAM use case. Strong authentication is also weighted heavily because many organizations will need additional assurance that the end user is a real person and not a bot or is a specific individual. This is particularly important in situations where the end user will have access to sensitive information that will require some level of step-up authentication or adaptive authentication. Profile and password management is weighted heavily for the B2C use case, since this capability is essential to rounding out a secure, unified, and compelling customer experience. Consent and privacy management is one of the key requirements in CIAM. Unlike in the workforce use case, when it comes to CIAM, the consent needs to be fine-grained, preferably at an attribute per application level. One of the most important non-functional requirements is the ability for the IAM system to be deployed globally in multiple regions. This is to support users across different regions with the best response time possible and being compliant to regulations regarding storing and using personal data. Especially if your organization is a multi-region organization with operations all over the globe, then you would be interested in looking into this multi-region deployment of the IAM solution. Some of the other key features you could find in a CIAM system is being omni-channel. That is, unlike in the workflows IAM scenario, in CIAM, users use multiple channels to access the system. They use desktops, they use web applications, handheld devices, mobile devices, etc. If you know the unique mobile subscribers by 2020 is expected to be around 5.6 billion. The usage of mobile phones have way surpassed the usage of traditional PCs. We have around 5 million mobile applications and 1.2 billion websites in the world. And most of the consumer e-commerce is happening through mobile devices. So it's very important for CIAM use cases to address mobile devices, making the security, the user experience simple. So now let us look at some of the trends which we can see that is currently happening, and how what we can see in the future as well. So one is the authentication arena. So what we see recently in the authentication arena is the use of mobile devices for two-factor and biometric authentication. that is the second factor and third factor authentication. For example, mobile push authentication, which leverages notification services, improves security and user experience while dramatically reducing the cost. Mobile push has emerged as the default commercial multi-factor authentication method now. It is more secure than one-time passwords because there is no passcode interception. And also it is more user-friendly than one-time passwords because the user doesn't need to type a long passcode. Mobile push, the cost of owning a mobile push or a push authentication system can be almost 70% less than other multi-factor authentication systems. In addition, adaptive authentication can be combined with many authentication methods while improving the usability. Most implementations of mobile push use the single-click acknowledgement mode. Their users only need to push a button to confirm they receive the push notification. But some implementations provide even higher assurance by asking users to authenticate before acknowledging the message using either local authentication capabilities such as the phone PIN or the fingerprint. The other popular authentication technology or emerging technology that we see is FIDO, which stands for Fast Identity Online Alliance, which supports two-factor and three-factor authentication capabilities. It is a standard for devices and IAM systems to integrate between different vendors who support two-factor and three-factor authentication. The alliance has strong support from over 100 members, many of which are enterprises and financial service providers. It focuses on passwordless local biometric authentication via a mobile device and hardware second-factor authentication. Recently, there has been also a standard API that has been developed under the supervision of the World Wide Web Consortium, that is W3C, for interoperability with web-based applications. But still what we see is that the adoption of FIDO isn't that high. Still people are having issues in adopting it. People adopt various proprietary vendor-based technologies by writing custom extensions, etc. But the day we adopt FIDO, we would not need to write custom extensions and spend money on owning and managing these extensions, etc. The other trend that we see is around identity analytics. Analytics makes IAM systems smarter. Identity analytics is the discipline that applies science to identity and access data to provide insights for making better IAM decisions. Identity analytics tools enable organizations to take a contextual, dynamic, risk-based approach to identity and access management. With identity analytics, the organization can bridge the gap between administrative controls and runtime access and context and risk awareness to access decisions, and continuously monitor, detect, and remediate malicious behavior. As of now, most vendors offer only descriptive and diagnostic analytic capabilities. Descriptive analytics describe what happened in the past, and diagnostic analytics determine why it happened. In future, we can expect to see IAM vendors offer more advanced analytics that move the market toward predictive and prescriptive analytics that automatically predict trends and behaviors, identify what may potentially happen, and make recommendations for corrective action. Advanced analytics will require IAM vendors to integrate with more data sources, aggregate and process larger amounts of identity-related data, employ behavioral and machine learning analytic engines, and provide algorithms optimized for identity domain. By using advanced analytics, IAM vendors will enable the following key features: risk scoring, computation and analysis, identity correlation and profiling, behavioral and data analysis, continuous monitoring and alerting, data presentation and visualization. Analytics can be strong need for two key areas in IAM. One is identity governance and administration, and the other is adaptive access control. In the context of identity governance and administration, it is largely driven by the need to improve access certifications. To ensure effective access certifications, organizations must add identity analytics data to their access certification process. Analytics data such as rogue or outlier access identification, peer group analysis, risk scoring, orphan and dormant account identification, and usage patterns provide context to help managers make faster, more informed access review decisions. Identity analytics also helps organizations make smarter identity governance policy decisions. For example, identity analytics helps enables more sophisticated role models that are based on usage patterns, peer group analysis, and role effectiveness. Also, it provides contextual data that simplifies the access request and approval process. The other usage for identity analytics is the crucial role it plays in reducing runtime access risk and improving user login experience. Compromised identity credentials, including credential phishing, are the biggest cause of cloud security failure. It is not enough to establish a user's right to access an application at administration time. Organizations must also detect and respond dynamically to attempted breaches in real or near real time by evaluating that the context of the request is appropriate. Factors such as environment, for example, IP, network, geographical location, time of the day, device or OS, etc. The history of the user, for example, previous successful login time, consecutive invalid login attempts followed by a successful attempt, geo velocity, and user behavior such as typing speed, etc. are used in establishing the risk score for a transaction. The other upcoming trend, or rather a regulation, is the GDPR. If you are in the EU or if you have operations in the EU, you should be familiar with the GDPR by now. The GDPR applies for any business in the EU, whether the users are residing in the EU or even if they temporarily come to the EU and go back to their country. Or the other way around, if the EU citizens move to a different country, still the GDPR applies. So there's a lot discussed in the GDPR regulation, but from an IAM architect's perspective, there are some key highlights we can point out. So one is decoupling the personal data from transactional and business data. So what this means is that store only the data relevant to IAM in the IAM system, and don't store transactional or business data in the IAM system, so that managing the life cycle of this data becomes easy for the IAM system. The other point is having an immutable private identifier and mutable public identifiers. So what this means is to internally have an immutable, unique, opaque private identifier for the users, but externally represent them using public identifiers such as emails, usernames, social identity numbers, etc. And whenever you store a cookie against the user's device, get the consent from the user. For each and every cookie, you need to get consent from the user. And then openly declare and get the user consent for the IAM privacy policy. That is how you are going to use the data that you collect from the user. This also has to be done at a per application level and a per attribute level. For each attribute, you need to inform the user and get consent. Then, like we defined the private identifiers, internally in our components, we need to use these pseudonymized system identifiers. For example, in the audit logs or in the analytics data that we publish, we have to use the pseudonymized system identifier. And internally, we will have a mapping between these system identifiers and the well-known public identifiers. So the advantage that this model gives is, if you want to delete or unlink public identifier and from the system, the user from the system, you just need to delete the mapping in the mapping table. If you delete the mapping from the mapping table, then basically the data is anonymized. Any other identifier, the private identifier, cannot be mapped to a real user. So this is the benefit of having a pseudonymized system identifier and mapping it in only one place in the system to a public identifier. Then of course, we are advised to collect only the minimum data required, not anything more, and collect data as and when you need it. As you go on using the application, if needed, you can inform the user and collect the data. You don't collect everything upfront. This is also sometimes known in the IAM world as progressive profiling, or knowing your customer gradually. Then whenever you share personal data that you collected about users to other applications, you need to get the user consent. You cannot share the data you have about users to other applications without user consent. And then also there needs to be a self-care portal where the users can come and log in and look at all the applications that have access to their data. And if they want, they should be able to revoke access to that data. And at any time, they should be able to delete the data, get an export of the data, etc. And finally, the user should be also able to do offboarding, which means he can go to the self-care portal and request to delete his account. So we know that in some systems, it might not be that easy to delete an account. Some systems don't allow to delete the account. But at least in those cases, we should be able to eventually delete the account after a period of 3 months or 6 months or 1 year. The account should be eventually deleted. But at that moment, the user requests to delete the account, we should be able to unlink the personally identifiable information from the user so that the data is anonymous. The next growing trend we see is Internet of Things, and more specifically, identity of things. Identity of things is a game changer in today's identity ecosystem. There are approximately 6.4 million connected things in the world. The diversity of the IoT makes identities of things hard to architect and manage for IoT solution architects. Users, devices, gateways, platforms, applications, and services all have a part to play in IoT solutions and need identities to form a secure and trusted IoT solution. However, the challenge is that you will not find one flow, credential, or bootstrapping method, authentication, or authorization method that will solve all these needs. Instead, you will have to work with a portfolio of tools in order to get the right solution. IoT solutions are built up of many pieces from various vendors, and this makes it hard to interoperate between these pieces. However, long-lived, adaptive, scalable, and maintainable solutions require integration to each other, especially for the identity of things. There are new and existing policies, authentication methods, federations, and trust needs to be used and reused to limit the amount of vendor lock-in and new identity silos being created. we can see that with the use case for IoT, the dreaded password is making a comeback on IAM systems, and this time it is coming at the edge of the networks. A one-size-fits-all kind of credential does not exist for all assurance needs in IoT solutions. But what we see is that a good and modern credential is both bound to hardware and is lifecycle managed. That is, basically we should be able to update and revoke the credential at any time we want. Another challenge is to govern and manage the relationships between users, devices, services, and policies. So given these considerations in IoT scenarios, we find that OAuth2-based federated identity ecosystem is a suitable candidate for IoT security due to the following reasons. One is that you can enable meaningful consent mechanism for sharing of device data. Tokens are much better than passwords because one, they can be revoked, and the other reason is that they are very granular in the permissions that they have. And also we can use the same model to access data that is from the device to the cloud, as well as from the cloud to the application. So the same model can be used in both paths. One of the problems with OAuth2 for IoT is that HTTP is not the predominant protocol. So OAuth2 is predominantly based on HTTP, or rather it's completely based on HTTP. But whereas in IoT, protocols such as MQTT is predominantly used. However, the latest working drafts of the MQTT specification explicitly calls out that one might use OAuth2 tokens as identifiers in the connect packet. So there are provisions in the MQTT specification to adopt various different authentication or access security mechanisms in addition to the plain, the old username password such as OAuth2. In fact, WSO2 has its own WSO2 IoT server, and in IoT server we have implemented OAuth2 to protect the device data. So one of the interesting specifications around IoT is the OAuth2 device flow. So basically what the OAuth2 device flow will do is basically, as a user, you can register your trusted devices with your identity and access management system so that your device can get an access token on your behalf to publish and consume data through APIs. So basically there is a user interaction at the beginning to register the device with the IAM system, and thereafter the device itself can generate and regenerate tokens to access the APIs. Another interesting specification around devices is user-managed access. Well, user-managed access is not directly was not written directly for IoT use cases, but it emerged from OAuth2. If you know about OAuth2, in OAuth2 we talk about how we can securely share a user's data to a particular application. So basically the application is getting access to user's data with his permission. In that case, the application, the data is basically owned by the application. But in the user managed access scenario or UMA scenario, we have another new entity which we call the requesting party. So the requesting party is actually a different application. So the speciality here is in UMA there is a different application which we call the requesting party who is trying to access data that is owned by another application. So basically a user is sharing his data between two applications that he works with. So this is the speciality with UMA. And if you extend that to devices, these two applications that we talked can be in two different devices. So then it becomes an IoT use case. So what we see is a federated OAuth2 based identity model can solve a lot of requirements that we have in IoT. And WSO2 IoT server implements some of these requirements already with OAuth2, and it's proven to work well. Then finally, we look at self-sovereign identity with blockchains. The reason why blockchain technology may hold the answer is because of the distributed nature of the platforms. Data is held and witnessed by every user on the network, and therefore hacking into and piecing together all the data points would be nearly impossible for the hackers. And because the only access point is through a privately held key, the entry barrier is insurmountable. Blockchain platforms like Self-Key, for example, have the power to protect individuals and change the way data is shared. The system virtually eliminates identity theft because the blockchain protocol ensures that authentication can only happen under the direct control of the owner of the identity. Unlike legacy systems where identity could just be authenticated via information possibly stolen from other databases, blockchain platforms control access by requiring personal identification keys which are held exclusively by the individual. Further, because data is stored on users' personal devices through a decentralized format, there is no centralized database where hackers can target for personal information. On many of these platforms, like for example Self-Key, the company itself doesn't even have access to the data, making personal identification completely user-controlled and secure, and making it impossible for data holders to monetize consumer information. At this moment, organizations are trying to address the following key issues in blockchain identity. How to generate, prove, bind, and manage a decentralized identity in an identity wallet. How to register and attest to a decentralized identity and its attributes on an identity trust fabric. How to protect identity wallets and enhance user experience using an identity custodian. How to verify identity and entitlement attributes for granting access in a digital transaction. How to ensure interoperability between components and establish integration standards. Decentralized identity systems consist of two key architectural components that a blockchain identity or self-sovereign identity tries to address. Number one is the identity trust fabric, what we call. An identity trust fabric enables the appropriate sharing of identity assets across people and organizations. Blockchain-based platforms run by groups of organizations operating in a preferably trusted network are playing a key role in enabling the current generation of identity trust fabrics. The level of trust in these systems highly depend on the quality of distributed consensus algorithms. These are currently open questions on the long-term viability of blockchain proof of work or proof of stake distributed consensus algorithms for identity trust fabric use cases. The key issues boil down to performance, efficiency, and the probabilistic properties of these algorithms. Many vendors are working on addressing these issues. However, most of them are still in early stages of industry review and have much less exposure than blockchain itself. The other key architectural component is the identity wallet. The user entity's identity wallet is another key component that directly affects the user experience. The identity wallet enables the user to manage the storage and presentation of their identity data, which involves the wallet owner in administrative activities. There is a general concern that in the case of a lost or compromised wallet, the user's identity history may disappear. These issues have raised the importance of the key management and application integration framework used by the wallet. Proprietary approaches to address these issues are emerging, such as multi-signature and escrow models that provide a wallet recovery mechanism, but standards do not yet exist. There are business models in which an identity custodian securely stores the wallet data in its environment to enhance the availability and recoverability of decentralized identities. So we looked at some of the five emerging IAM areas that we can look forward to. One is the authentication, the next generation of future of authentication, GDPR, IoT, and identity analytics, and blockchain-based identity in future. So the identity servers release themes for this year is also going to be around some of these key technologies that we talked about, mainly around the future of authentication based on adaptive authentication technologies, identity analytics, GDPR compliance, and support for IoT and microservices architectures, security architectures. So there's a webinar series that is coming up next this quarter, completely dedicated to GDPR. So the first webinar in this series is to be happening on the 21st of March, which will be titled Accelerating Your GDPR Compliance with WSO2 Platform. So you can find more details about this webinar in the link provided, and there are a series of webinars that will continue from this webinar. So if I talk about some of the timelines, so the next release of the identity server is the Q1 release, which is IS 550. So this is mainly focusing on GDPR and PSD2 compliance. So it will have improvements around pseudonymized identifiers, anonymizing the data that is written to logs and analytics streams, and fine-grained consent management for attributes, for individual attributes, at an application level, etc. Then the Q2 release theme is going to be adaptive authentication and identity analytics. This is where we are going to focus on providing a programmable framework, programmable using not Java but different programming model, more of a declarative programming model for adaptive authentication. And this will be internally using a lot of identity analytics that we generate. So this can cater for use cases like step-up authentication, conditional authentication, etc. Using the identity analytics data. So it can use data like environmental data like IPs, networks, devices, OSs, using device fingerprinting techniques, etc. And then contextual data like, for example, when did the user successfully log in last, or from which geolocation did the user log in previously, etc. And then the Q3 release team is going to be focusing on the UIs of the identity server, the identity admin portal, and the user portal. So the identity admin portal is going to be a completely new UI for the management console that we have currently. It's more of a business user-friendly UI for the identity management. The current UI, the current management console, is more of a DevOps kind of UI, or rather administrator kind of UI. But the new identity admin portal will be more of like a business user friendly UI. And then we also have the user portal, which will be like a one-stop shop for all the end user related operations that needs to be done, which we currently also have, but this will be more enhanced. Basically, it will support all kinds of two-factor authentication options, registering devices, etc. And also there will be capabilities for to discover applications that have been authorized for you to access. So you can go to the user portal and find out the applications that you can access and access it from there. So it's an application discovery portal as well. So these are the release themes that we lined up for this year. Yes. So that basically brings to the end of this webinar. So if there are any questions, we have a couple of minutes. We can take in some questions. So one of the questions we have is whether we have Kerberos access. So it's like this. So identity server cannot function as a Kerberos key distribution center like an Active Directory, for example. It cannot issue Kerberos tokens, but what it can do is it can use the Kerberos tokens or NTLM tokens and provide single sign-on. So that is possible. So for example, this is the technology behind integrated Windows authentication in a Windows environment. So it uses Kerberos or NTLM and does IWA. So that technology is available, but identity server itself cannot issue Kerberos tokens. But we can integrate, we can support use cases around Kerberos tokens, like for example, like I mentioned, the IWA use case, or else if you talk about accessing APIs, in our API Manager product, we can exchange NTLM tokens or Kerberos tokens to OAuth 2 access tokens. Then there are also use cases where we can do constrained delegation to access backend services that are protected by Kerberos security. So these kind of use cases around Kerberos we can support, where predominantly we function as a Kerberos client, but we can't issue Kerberos tokens per se. Yeah, so there is another question asking on, are you considering to include any blockchain related functionalities in identity server in the near future? So this is a very early stage. So there is a lot of research and studying going on. So I don't think it's going to come, anytime soon. So there is a lot of potential in the technology, but when it comes to identity, standardizing stuff it takes quite a lot of time. So even if we know that the technology will work to make it standardized and bring it to the industry and adapt it and make people adapt it, is going to take time. So I don't think we in WSO2 will be investing on blockchain anytime soon, but we are keeping our tabs on this technology so that whenever there is something, we will look into it. So another question is when is it recommended to use soft token versus hard tokens? What are the pros and cons? Do we have any white papers on the for various industries like banking, finance, healthcare? So unfortunately, we don't have white papers, but we see mostly is hard tokens are mostly limited to internal enterprises. We don't find hard tokens outside of the enterprise. So employees are the ones who mostly use hard tokens like RSA or smart cards to authenticate to internal applications. Whereas when it comes to the customer IAM scenarios, it's mostly the soft tokens because of the ease of adoption and the widespread use of mobile devices, etc. So it's mostly technologies like SMS OTP or TOTP, that's the Google or Microsoft Mobile Authenticator, etc. So yeah, so we don't find hard tokens widely used in the customer IAM scenario. So this is also like one of the reasons why still FIDO, the U2F standard, didn't get much traction, because it was a hard token based two-factor authentication. So people need to purchase the token from a vendor like Ubico. So it didn't get a lot of traction from the customer IAM use cases. But of course, there are certain companies that use these technologies internally. Yeah, so there's another question like what kind of governance practice maps to which IAM model? Do you have any known guide on the same? So yeah, so when it comes to identity governance, identity governance is a strong requirement in the enterprise IAM scenario, mainly for the enterprise applications. We don't see identity governance requirements much in the customer IAM space. But features like access requests, access certification, segregation of duty policies, role mining, these kind of requirements are mostly found in the enterprise IAM scenario, and also like provisioning accounts to like application targets and syncing passwords. Yeah, so these kind of requirements are there in the enterprise IAM scenario, but we don't have much like a guide on this. But of course, if you have any like specific questions, I'll be happy to answer. If you can send them to me directly, maybe after this webinar, around identity governance practices and technologies, I can answer. But yes, we don't have like a guide as such at this moment. Yeah, so I think we've almost run out of time now. So if there are any other questions around what we discussed today, or like in general on IAM or the WSO2 Identity Server, you can always send me your emails. I'll be more than happy to answer you. So yeah, so until we meet next time on a different webinar topic, have a nice day and goodbye.